as we talk about scientific notation, we need to understand why we even use it. So I said here we use it for very large, very small numbers. Okay, and I'll give you my definition of large and small in just a moment. But as we go through the lesson, think of ways, why would I even want to do this? Like what's even the purpose of this other than just to write them in a different way? So scientific notation is a special way to write numbers, and that is used for large and small numbers. Okay, I'm ready to move on here. You need to know the form of scientific notation. Go ahead and write this down, and then if you're like, what does that even say? Write it down, and then I can explain to you. You can fill in some notes if you need help, but I'll try to explain that. Notation of symbols, numbers, variables, all that kind of stuff. So scientific notation has a special form, and I think you guys have done this before, I'm assuming. Okay, maybe not, and if not, that's okay. If you have, great. If you haven't, that's okay. And it's a times 10 to the nth power, or to the power of n. Whoa, that's strange. Okay, a has to be a number that is greater than or equal to 1, and a has to be less than 10. So basically, the way to summarize that is this number a has to be a number between 1 and 10. Has to be a number between 1 and 10. And then n, which is this exponent, has to be a integer. What's an integer? I know Alex knows.
Integer.
Hudson?
It's every whole number and its opposite.
Yeah, every whole number and its opposite. Good. So is 10 an integer?
Yes.
Negative 2?
Yes.
Negative 1/2?
No.
Okay, so we're talking about integers for this exponent. I mean, is it possible to get negative fractions and decimals as exponents?
Yeah.
But we're not doing that, and that's not the proper scientific notation form. Yes, ma'am?
Oh, okay. So at the top, where you wrote A and something 1, what is that? Is that supposed to be?
Yeah, this is A is greater than or equal to 1, and A is less than 10. These inequality symbols, you may have seen them before. Guess what I was talking about in Algebra 1 today? Those symbols. So you think we're going to go over it again?
Yes.
Yeah, so soon you're getting this. Oh, I saw that. I've seen that. I know that because you've been re-exposed to it many times. Hopefully. Yes, sir.
So going back to this, does anybody send those in any classes?
The last two? No. Actually, I don't know about Spanish. I haven't looked. Spanish is pretty packed in here, so maybe use. Why?
Well, I was wondering if I could maybe switch out my desk for one of those accounts.
Yeah, you know what? Do you mind holding off for today, and then I'll switch them out. Sorry about that. We're going to get that fixed. Okay, so write this down here. And again, I'm going to summarize this. A has to be a number between 1 and 10, and n has to be an integer. Let's look at our first example. Okay, 186,000. I consider that a big number. So I'm going to put big number. And you're like, that's not that big. Well, here's my definition of big. Greater than 1 is big to me. Greater than 1 is big to me. You're like, that's not to me. Okay, I was reading my son, The Magic School Bus. You guys know those books, and they had a cartoon too, but like the books, it was about the solar system. One of the students has like his cousin visiting. So the cousin keeps saying, after Miss Frizzle gives a fact, you know, we've been to this many planets, class. My teacher has taken us to more planets. We've been in temperatures warmer at this temperature. My teacher has taken us to hotter temperatures. So they kept saying, they kept contradicting or trying to one-up what Miss Frizzle was doing. This is a big number because it's greater than 1. If you want to one-up it, that's fine. But just consider it. Bigger than 1 is a big number. Can we use that definition? And this is going to help you when we do this problem and other types of problems. Okay, so here, what I do is I'm going to rewrite this number just to show you my work, because this is the original. Is this number in between 1 and 10? No. Can I make it a number between 1 and 10? I can. First, I have to identify where's the decimal point.
After all 3 zeros.
Yeah, it's right here. That's where the decimal point is. In fact, any whole number that doesn't have a decimal point has a decimal point at the end. Okay. I can move that decimal point and make this into a number between 1 and 10. If I move it, will that make it a number between 1 and 10? If I moved it here? 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 You're like, where do I move that decimal point? You have many options already. You have many more if you really wanted to check. There's only one spot where I put that decimal point where it makes this number between 1 and 10. And that spot is right there. It's right here. Okay, what's that decimal number now? 1.86. And don't forget the zeros drop out in a decimal. Is this number between 1 and 10? Yes. Why wouldn't it work right here? Oh, that's 0.186, and that's not between 1 and 10. Oh, what about right here? 18.6. Oh, that's not between 1 and 10. There's only one spot, and it's right here. Do you guys understand where I pick my spot? And there's only one spot in every problem. Yes, ma'am.
I'm just confused on what we're trying to do.
You're trying to write it in a different way, and you'll see. We're not done yet, because you'll see here something. All right, then scientific notation form says, all right, 1.86 times 10 to some exponent. Now, how many times did I move that decimal place? Does anyone know? 5 times. That's the exponent. That's scientific notation.
Is that all we're doing today?
Like this. I have some other things. I have a few more slides here. Okay, this is one of the things you're going to be doing, like type of problem. Now, look at the original problem, the original number, I should say, and look at the scientific notation number. They're the same number. We didn't solve. We didn't change anything other than the way it looks. This number is the same value as that number. That's all we're doing. We're converting it to a different way of looking at it. And what type of notation is this? Scientific. Okay.
So that problem started to be in the purpose because it takes up more time and it takes up even more space than the other.
On scientific notation.
So we got to figure out what's the point of it. Yeah, we'll wait for that. Okay. This number is a positive exponent. You guys see that?
Yes. You always times it by 10.
Yes, always times 10 to some power. Always. Positive exponent. Positive exponents are used for big numbers. And you're like, big numbers? What do you mean by big numbers? For me and for you, greater than 1. Greater than 1, really? So you're saying 2 is a big number? Yeah. Because I'm comparing it to smaller numbers. So you'll see what I mean by smaller numbers. Okay, by the way, this number, great, 186,000. Cool number. Okay, that is actually something in science. The speed of light in meters per second. Okay, would you say that's fast or slow?
Fast.
Speed of light.
Wait, fast.
Speed of light. Okay, it's basically 186,000. You can even say yards per second. So think of 186,000 yards, and in 1 second, light has already traveled that.
Sorry,
You're like,
186 football fields?
186,000 football fields, 1 second. All right, turn off the lights, Hudson, please. Is that pretty fast, though, by the way, guys?
No,
Okay.
it's too slow. I can see
I'm
the
not
ones
about
that are
93.
gone and all.
All right, now this is what we're going to do, Hudson, in just a moment. That's what 186,000 refers to, meters per second. But how long will it take for light to turn on and go through this room, like light up the whole room? So we're actually going to figure that out as best we can. Some of us will be a little bit off. Okay, Hudson, before you turn on the light, this is what I want you to do. As soon as you see that light come on, think of how many seconds it'll take to go across the room. And it's not when he flips the switch, because electricity takes longer than light. Okay, they're not the same thing. Okay, so go ahead and turn it on. Once you see the light, see how long it takes to get across the room. Go ahead.
No.
Okay. So keep your thoughts to your head. I'll give you the answer in just a moment.
1 to the 74th power.
Let me review this. Let me review this. Is this a big number? Yes, because it's greater than 1. So I have scientific notation, and what kind of exponent? Positive. Here's the answer. It took 100 millionths of a second.
How did you get that?
I didn't get it. I can't measure it. My eyes can't do it. I had to look it up. And this is a cool fact here, guys. Ready? If I had a second, okay, so a second would be this. Ready? Start 1. That time, start to 1 is a second. Ready? Start 1. Okay, that's that time. If you divide that time into 100 million slices, 100 million slices, a lot of slices, right? How many of them would it take light to travel the room? 2 of those. Is that pretty quick?
Yes.
Very quick. So we would say the time it took light to travel through the room is a very, very small amount of time. You agree with that? Small amount of time, like super quick. None of us could detect it. In fact, your eyes are doing this. As soon as you saw the light come on, it's actually kind of cool. Before you even registered it, it was already through it. It was already through the room. Because our eyes don't detect that speed. In fact, even if I had a camera and slow-mode it, yeah, I still don't see it. What if I slow-mode it even slower? Didn't detect it. You need special instruments for that, and I don't have it. How many of you would consider this a small number? So would I. I think it's very small. Small number. And this is going to help you to actually convert standard to scientific. And my definition of small number is less than 1. It's less than 1. So you're saying 1/10 is small? Yeah, 1/10 is small. 9/10, is that small? Yep, pretty small. Anything below 1 is small. All right, let's see how we treat this one here, guys. I'm going to rewrite it again, to show my work. 1, 2, 3, 4, 5, 6, 7, I believe. 1, 2, 3, 4, 5, 6, 7. And then a 2. All right, I'm going to rewrite it in scientific notation. This is standard form. This is how you normally look at numbers. And then I'm going to write it in scientific notation. Okay, right now, is this number between 1 and 10? What do you think? Is this between 1 and 10? No way. Tell me when I stop. Tell me where to put my decimal point to tell me if it's a number between 1 and 10. All right, should I stop here?
No.
Right here, right? You guys agree with that? What number would that be? 2. And you could say 2.0 or just 2, which 2 is fine. And then it's going to be 2 times 10 to some power. How many times did I move that decimal point? 8 times. And it's a negative 8 exponent. Negative 8 exponent. You're like, wait, what? Negative exponent? Okay, here's a little note. If it has a negative exponent, negative exponents, small numbers. Yes, if you want to call it if you want to call it a fraction less than 1, I'm good with that. So basically anything less than 1, small number. What kind of exponents do small numbers have? Negative ones. Let me answer it in a little bit, but I'm a little confused about the positive negative part. Guys, you already knew this. You already know that positive numbers are large numbers and negative exponents are small numbers. You already knew this. Positive exponent? What's 5 to the second? Is that greater than 1?
Yes.
Okay, we agree with that?
Negative.
1 over.
Whoa. It has a negative exponent, doesn't it? And isn't this number smaller than 1? You already dealt with this. Positive exponents greater than 1. Negative exponents less than 1. But I'm not saying it's a negative number. Is this a negative number? Is this a negative number? No. But it is smaller than 1. This is also positive and it's greater than we already dealt with positive and negative exponents. So I hope you understand that we're just applying it here to scientific notation, which is our second chapter. Starting our second chapter. Yes, sir?
So in decimal form, would that be like point?
Oh, this one?
Yeah, like could it be 0.4 to the 10?
4 hundredths.
Well, it could be point.
0.04.
Yeah.
Mm-hmm. All right, let's move on here. We're going to convert these two numbers from standard form to scientific notation form. Now, some of you have your thoughts about these. I'm going to ask after we do these problems, why would we even want to do this? I don't mind looking at this number. I don't mind looking at that number. Okay, what's the whole point of this? We're going to answer that. Okay, but first, let's get this in scientific notation. Is it in scientific notation? No, it is not in the form a times 10 to the nth. Doesn't even have a 10, no multiplying, no exponent. So now we have to think, where do we move that decimal point so that it's a number between 1 and 10? Brad?
Oh, I was going to give you an answer, but would you move it between the 4 and the 5?
All right. Right here?
Yeah.
Okay, so you get 4.5. That's correct. Did you have a question, Brad?
I was just going to give you an answer.
Oh, okay, that's all you want. All right, fine. Yes, ma'am?
So
Yeah,
every
Grace?
time you move it over, do you just have to have one whole number in front of the decimal?
Yes, you could say that. Or you could say this is a number between 1 and 10. All right, and then it has to be times 10 to some exponent. Is it going to be a positive or negative exponent? Why negative? It was a small number. How many times did I move it?
3.
So it's negative 3. That's my answer. That's scientific notation. No.
What's the pH for?
You'll get them. Let's do the second one. Here, we're not even done with this one. Okay. Eva, big or small? 57 billion? 650 million. Okay, I think we agree that's big because it's greater than 1. So that's my definition, greater than 1. All right, is this number, Henry, between 1 and 10? No. So I'm like, oh my, I don't even know where the decimal point is. Oh wait, it goes at the end. So where do I have to move that decimal point in order for this to become a number between 1 and 10? Matthew.
To the top,
Which one?
the one, or not the 6 to 5, but 5.
Yeah, right here, right? Okay, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got 5.765, and then you drop off all those zeros, times 10. How many times did I move it? 10 times, but is it positive or negative?
Positive.
Why is it positive? Because it was already a big number. Show me that by keeping it positive. Do you guys get that? Yes, ma'am?
Okay, so are you so basically the decimal point has, where the decimal point is, has to make the number between 1 and 10?
And then however many times you moved it, you give me an exponent. The sign of the exponent is based on, was it a big number, greater than 1, or a small number, less than 1? Now, I need to ask this question before we go on, because we have one other part, which is still going to use this idea. Why do we, what? I don't need this. Anyone know? Give me some application. What do you think might be the reason we do this? Yep, Alex?
I mean, I guess because it's just too big to like do common stuff with it. Like it'd be too big to divide, maybe, or it just makes it easier.
Did I tell you guys about my 60 things that I want to accomplish to show that algebra is easier than arithmetic? Okay, 60 things. This is the second thing. This is going to make math easier.
I agree.
Now you're like, I'll show you guys tomorrow that making numbers in scientific notation actually makes your math easier. It changes it from this giant multiplication or division problem to something simpler. Anyone else know why I would change it? So let's say it didn't make the math easier. Why would I do this? Yes.
Easier to say.
It's very easy. Like, guys, what was that number again? You're like,
7 billion.
Good, got it. 5 and 765 thousandths times 10 to the 10th. Super easy to say, and it takes a little bit less space. Any other reason?
It's just simple.
It is simpler, yeah, and that's, it takes less space. And I can compare things very easily. Like, guys, which one's bigger? Now.
Equal.
Sorry, these.
Oh, I thought you were talking about.
That's okay. This one and this one. Which one's bigger?
The number 2 because it's positive.
Yeah, it has to be smaller than that one. Easy. No, I'm not even like, nope. Positive. I'm just looking at a positive and negative. Or if they were both positive, let's say, which one's bigger?
That one because.
Positive 10 is bigger than positive 3. Easy to compare. We're going to look at these things as we go through this chapter. We're making math easier, despite what maybe some of you might think. Okay, let's go. This is the last part we're going to do, writing in standard form. So what we have been doing is we have been writing standard form numbers into scientific notation. Now what I'm going to do is write scientific notation into standard form. So we have to be able to convert back and forth. Hold on, sorry. You have an answer?
No, I think I know what we have to do.
All right, what do you think you have to do?
So the 10 to the 5, like for every 0, you move it over 5 times.
Okay, so move it 5 times. But do you move it 5 times to the right or to the left?
To the right.
Why?
Because it's positive.
And that positive number, or positive exponents mean it's a big number. All right, here's what I'm going to do. You start off with your decimal number, 4.56. And this is the trouble, this is like the eternal struggle for students in scientific notation. Which way do I move that decimal point? Here are my two options. I either move it 1, 2, 3, 4, 5 times over here, fill in those empty spots with zeros, or I move it 1, 2, 3, 4, 5. Right here, fill in the empty spots with zeros. Only one of those was correct. And there's a very simple way to know which one was correct.
The right hand.
Why is the right hand? Wait, this left one, it looks really good.
Because it's a big
Oh, it is a big number. Because of what?
It's bigger than 1.
The exponent is positive, yeah. This number looks good. I moved it 5 times, didn't I? That's what I'm supposed to do. But this is a very small number. The original was big. So that's my answer over there. 456,000. Has to be that one. Can't be 456 10 millions. It can't be that one. Okay, you guys get that one? Let's go this one. Go ahead and try it out. You guys try it out. See what you get on this one. And I'll ask you guys some questions as you're working through it. Jackson, big or small number?
Small.
Small number. Why, Jack?
Because it's the exponent's negative.
Exponent's negative. Good. So I can move the decimal how many times? 3 times. And only one direction is going to get me what I want.
To the left.
1, 2, 3. Yay. Or 1, 2, 3. Yay. It has to be this version. How many of you got that? Like you get this? Okay. What I'm going to do now is this. I'm going to give you 2 problems. If you get both of them right, it's individual, by the way. It's not a class thing. If you get both of them right, I'll give you the homework. You can get started. If you miss one of them, I give you extra ones to help you figure it out. So try your best. Yeah, I know. Man, we got to try. Can't believe this.
Wait, so if we get it
Yourself.
okay, for yourself.
For yourself. Don't worry about your neighbor. You're doing you. Yeah. Well, I'm trusting in your honesty, and I'm watching. Like if I'm seeing, because I see those eyeballs, and it's kind of awkward.
Yeah.
I'm not looking at you. Oh wait, you can see that? Okay. Just be honest. Do your best to cover it up. All right, go ahead. This is the first one. Get this one right. I want to change it. Do I want to write this in scientific notation?
No.
It's already there, so you need to write it in standard form, how we normally see numbers. And go ahead and try that one out. And there's only one answer for this, so I hope you get it.
Can we look at our notes?
I already picked my volunteer.
Oh, Mr. Ray.
Okay. Give you about 10 seconds to finish up. And be honest again. Oh, I got it right, Mr. But you really didn't. So you're willing to lie about something to get homework a little bit quicker. So,
Just get all the problems wrong.
okay, Mary. What's your final answer? Just tell me, okay, it's 1, 4, then where do you put the zeros?
You put the zeros to the right.
How many do I have?
12. Or,
You can count them up because there are a lot.
okay, sorry. 11.
11 of them. All right, I didn't mark off on this one, but if it's a big number, guys, you need to have commas. Because when you just have a number with a bunch of zeros, when it's a bigger than one number, no one, I mean, you're like, I don't know. So put the commas. What number is this? 1,400,000,000,000. All right, to give you some context, how many of you agree that's a big number? Okay, this number represents the total number, the total amount owed by college students in student debt in our United States, 1.4 trillion. So all the people who owe money for college altogether, that's oh my.
Bill Gates' house.
Yeah. Okay, and guys, this is what we're trying to say. The national debt is, I think it's like 10 times that big. So 1/10 of the debt is how much people owe for college expenses. So is that a significant portion?
Yes.
And that's the highest personal debt that people tend to have. College debt is the highest.
I'm guessing a lot of that comes from questions.
All right, hold on. I have one question here, and I can't even hear it. I'll wait. Because remember, you still need that second problem before I give you that homework. Yes, ma'am.
Okay. I got the commas wrong, so would that be considered wrong?
Did you get the 11 zeros?
Yes.
Oh, just be careful. Start here, go 3. That's okay. No. But on the homework, it will be wrong.
Wait, if we don't put the commas, it's wrong?
Yeah, on the homework. Yes, I will mark off for commas. I know, it's cruel, unjust.
Oh.
All right, so do this one here. This is the second out of the 2. If you get this one right, you'll get your homework. Okay, I'm going to ask different people questions and then I'll get the answer. Natalie, big or small number?
Small.
Small number. Why is it small? William?
It's small because it has a negative.
Negative exponent. Good. What's your final answer? Philip?
0.0000000. Is that 6 zeros?
1, 2, 3, 4, 5, 6.
I got 5.
35
Trillion?
So here's how I go here. 100 millions. 100 millions. Okay, you know what's cool about this? This is kind of amazing. 3,500 millions is a very small number. Okay, if you get any object length, let's say, cut into millions, 100 millions, wow, 100 millions, 35 of them would be that length. Very small. What does that represent? Anyone colorblind in here? Oh, wow, okay. Okay. Okay, my father-in-law is colorblind, and that could pass on. So I don't know, my kids are colorblind, but anyway, colorblindness. Red and green colorblindness are off on the spectrum of what someone can see of the colors. 3,500 millionths of a millimeter. Okay, a millimeter, guys, I can't even show you because my fingers are too spaced out. And if I divide that small amount into 100 millionths, 35 of those little slivers would be the difference between what they can view on the spectrum of light. That's the only difference. That is like, how do you even measure that? I can't. That's why I had to look up and see scientists did that. But think of it like this. Is there a huge difference between red and green color blindness?
Yes.
Think of the amount of wavelength of the millimeter. Not really, right? But isn't it a big difference, like how you actually see things? Okay, think of it like this. Who gives vision?
God.
Who created it?
God.
How did he create it?
Perfect.
Words.
He said it. It happened. Now think of it this way, guys. He spoke that part of your vision, which is part of your eye, which is part of your body, which is a small part, by the way, of the total function of your body. And he spoke that and it happened. And how did he describe it? It was very good. Guys, this God, this Creator who spoke things like that, and there are lots of things going on all over here, he did it by speaking it, by the power of his word. And the cool thing, even beyond that, guys, he wants you to get to know him. He wants a personal... Okay, I don't even know what's going on in my body. I know it's wonderful. I know it's marvelous. But as I study it, I start figuring out, wait, it is really complex and awesome. And the person who spoke that wants to get to know me. That's awesome. Also, I want to think of it like this. Science, guys, I value science. Because if you understand more about science, you understand more about the person who developed all those by doing what? Speaking. Where I would take my whole lifetime to get one aspect of that creation and not even figure it all out. And he knows it all, and I get to know him. That's awesome. All right, your homework. 232, pages 39 and 40. You want me to change it?